Alright, 5 to number 4, you're finding vertical, horizontal, and oblique asymptotes, if any, for the following rational functions. So I'm trying to give you a little background information here. If you've got any function, it's basically a numerator divided by a denominator. And you kind of want a lot of times look at f of x and it's reduced to its lowest terms to figure out some of the things. For the vertical asymptotes, basically you look at locating the zeros of the denominator. And whatever that is, that generally produces a vertical asymptote. Horizontal asymptote is the tricky part. You look at the degree of the numerator. Well, in this particular problem, it's 1. And the degree of the denominator, it's 1. It's the highest exponent that's there. And if the degrees are equal, in this situation, they're equal, it's the ratio of the lead coefficient. So that's 15 over 1, so it would be y equals 15 for that horizontal. If the numerator is less than the denominator, it's going to always be 0. If the numerator is greater than the denominator, there is no horizontal asymptote. There's a possibility of being a slant or an oblique, as we refer to them a lot of times. And this happens only if the degree of the numerator is exactly 1 more than the degree of the denominator. So like if I had x to the first on the bottom, I'd need x squared on the top. If I had x squared on the bottom, I'd need an x cubed on the top. And then you divide the numerator by the denominator, and your result is your slant asymptote. You don't have to worry about any remainders. You just divide it and disregard the remainder for that. Now, actually looking at this problem, your vertical asymptote is at -7 because that's what makes that denominator 0. Your horizontal asymptote, 15 divided by 1 is 15. Powers are the same, and there is no oblique.